In the previous module, I was explaining about the create statements, alter statements. In create statement, I was explaining how to create tables, and then creating primary keys, creating foreign keys. And at the same time, I was also explaining how to drop the tables also. Now in this module, we are going to learn something about data manipulation language, which focuses on insert, delete, and as well as update statements. To practice this one, I am going to use this Oracle database. Oracle database is free for everyone. You can also go to those URLs, download Oracle, and you can also practice by yourself. Now in this module, we are going to learn these three data manipulation commands: insert, update, and as well as delete, select statement, and moreover we are going to talk about this null and not null, aggregate functions, and how to use group by and having classes, then few statements related to alter table. As a data modeler, the fundamental is you need to learn how to create tables, how to create primary keys, drop primary keys, drop foreign keys, create unique constraints, drop unique constraints, because at times you'll be asked by the DBAs to give those scripts and you should be in a position to give all of those things. I have various slides in this data model. One by one, I will try to explain everything by executing those commands in the Oracle database. Now, let me execute the first statement. When you see this command, it says select. That means select the data, that is the syntax. Then patient ID, visit fee. These are two columns present in patient visit table. From is the syntax. Where is the syntax? Visit fee is the column name, and is null is the syntax. Altogether, what I am trying to do here is pull data from this patient visit table where the visit underscore fee is null. Let me execute the statement. You got two records, P5 and as well as P9. Then let me go to the second statement. So what you understood from this, P5 and P9, they don't have any visit fee. That means they have not paid the fees to the doctor. That is why these two columns are showing null values here. Then I'm going to give an update command. So update command is used for updating some information in the database. So update patient visit. That means update is a syntax. Patient visit is the table name. Set is a syntax. Visit fee is a column name. And I'm setting that value as 120. Where is the syntax? Visit underscore fee is a column. Is null is the syntax. So it says two rows updated. What I'll try to do? I'll try to execute the previous command. In this situation, it should not show P5 and P9 as the response because we have already updated those two records to visit underscore fee is equal to 120. Yeah, it shows 0 rows updated. Then I will go to the next command, rollback. Now, whatever we do with Oracle, those update statements or delete statements that are stored in the memory and it is not pushed permanently into the database. If you want to undo some changes, you can use this rollback command. Now, what would have happened? Whatever update statement we gave here, those changes will not be there in the database. So I'm trying to execute the previous command here. Select statement. So you can see P5 and P9. Now you can understand the importance of rollback command. First, there were two records P5 and P9. Then we later updated this table. So we got 0 rows. Then we gave the rollback statement. That means these changes are not stored permanently into the databases. Then it gave us P5 and P9 as the feedback. That is the importance of the rollback command. Now, I am selecting patient ID visit fee from patient visit, where visit fee is equal to 120, And here I am changing the where class with clinic underscore id is equal to C3. So it gave me an error message quote string properly not terminated. Fine. That means in the presentation document, when I type this quotes, it is not typing well. So it gave another quotes there, and that is a problem you see there. So what I do, I type this quotes here and execute it. So this code is perfectly fine and is able to execute the result. Now what you have seen, I have selected two select statements here with visit fee is equal to 120 and clinic ID is equal to C3. In both of the situations, you see the records here. Then the next step, what I do here is I'm going to delete those two records and let us see what happens here. So two rows are deleted. Just I want to make sure, I'll go to the previous statements and we'll try to execute those statements. C3. So it says quote string not properly terminated. So I will say C3 here. No row selected. That means what has happened now, earlier when I gave the statement, it was showing some records, but since we deleted that record, it is not showing any record here. Now I will go to this rollback complete. Again I will to give the select statement. Let me see what is the result here. You can see P10 and 150, that is the response from the select statement. Why? The rollback, what it did, whatever action we did with the delete statement, that was not permanently committed to the database. So it pulled the data and it displayed on the screen. So the fundamental thing what you have to understand is, when you're doing something, it is not permanently committed to the database. Only with the help of a commit statement, or when you create tables, alter tables, drop tables, then only those records are permanently pushed or taken out from the database. And that is the importance of rollback command. I will go to the next section. Now, instead of typing like one by one, I'll try to type 4 or 5 commands so that you can understand it. Right. Now I'm describing the patient visit table. It is giving the structure of the patient underscore visit table. Then if you want to find all records, then I'm using star, select star from patient visit. It shows 10 rows selected here. If you want to select only few columns like patient ID, clinic ID, then I give these two columns, patient underscore ID and clinic underscore ID from patient visit. Then it gives these two columns here instead of pulling multiple columns in the database. Then to find out the number of records, I'm using the system defined function called count of star from patient visit, which shows 10 records here. Then I'm using the where class in the statement. I'm trying to give where visit underscore fee between 100 and 120. You should not think that okay, between 100 and 120 means it will give values which is between 100 and 120. It's not like that in Oracle. It will also include 100 and 200, and you can see the results here. It says visit underscore fee is equal to 100 and visit underscore fee equal to 200. So those records which are in the range of between 100 and 200, all records will be displayed here. Then distinct class is used to avoid multiple values. So here it shows 6 rows selected. That means this null is having a duplicate record. This 100 may have duplicate records, and that is why those duplicate values are excluded and it says select distinct visit underscore fee from patient visit. So to count of values in a column, okay, I'm trying to find out how many columns, how many values are in this column. So it gives 8 values here. And when you want to see distinct values of visit underscore fee, only these values are here. And that is why we're able to see this 6 rows selected. These are very simple commands, but very useful from the data modeling perspective. I'll go to the next slide now. Now, these are simple operators where I'm using equal to operator, not equal to operator, greater than equal to, less than, and less than or equal to. Visit equal to fee equal to 100, it shows 3 records. Not equal to 100, it shows 5 records. Greater than 100, 5 records. And then greater than equal to 100, it shows 8 records. And then visit fee less than 100, no records are there, that's why it shows no row selected. Lesser than equal to 100, then it shows all these values of 100. Now, I'm going to use this AND operator and as well as the OR operator. Let me clear the screen. Now, if you see this first statement, to select using AND operator, it is giving an error message. What is the reason for this one? Let me go to my statement. Here, to select using AND operator. Just give me a second. To select using AND operator. Yeah, this is a statement. Okay. So let me put in the right way. So what I'm trying to do here first, equal to 100 and clinic underscore ID is equal to C1. That means when you see the statement, I'm giving AND class here. What does the AND class do? It has to find out where visit underscore fee equal to 100 and will also find out clinic underscore ID is equal to C1. Now, how it is being executed in the database? When the select statement is given on this particular table called patient underscore visit, first this where class is executed and it takes out all records which has visit underscore fee. And then it takes all records which has got clinic underscore ID is equal to C1. Then it sees whether both of these conditions are satisfied. If visit underscore fee equal to 100 and the clinic ID is equal to C1, then only that record is pulled here, C1 and as well as 100. Now, when you see the second one, OR operator, again I'm using the same condition. Here what happens, where visit underscore fee equal to 100, it puts the records, it stores in the memory, and then again it puts records and it stores in the memory. Then both of them are concatenated and displayed, and that is why you see 100 also here and C1 also here. When you see 100 here, you can see C1 also here. When you see 100, you don't see C1, it says C2 here. That means when one of the conditions is satisfied, it is able to pull all the records. In operator, it's similar like OR. So instead of using OR, you can use this in operator. What I've done here is 100 and 150. Here, you can impose this condition on only one column, visit underscore fee, whereas the OR class, you can impose a condition on multiple columns. So here in this part, what I did, visit underscore fee in 100, 150. If I'm able to get these values, then I'm all set. So when you see the response, you also see 100, 150, 100, 100, 150. That means the system is able to fetch records which has got this visit underscore fee is equal to either 100 or 150. Then not in is the opposite of in operator. Wherever 100 and 150 is found, it will exclude those records and all other records will be displayed here. Here you can see 200, 250 and 120, and this 100 and 150 are not included. Now, here I specifically talked about is-null operator. This is very useful operator, and you can use this is-null and you will see this P5 and P9. This is a revision. I execute this statement in the first slide, and again I am trying to execute the same statement here. So if I go to the next one, I am talking about a subquery here. What is a subquery? A query nested within another query is called a subquery. Which is a nested query? This query is called as nested query. Select patient ID from patient visit where visit underscore fee is null, and this is the main query. What I'm trying to do here, first of all, this subquery, this nested query will be executed, and it will pull all records where visit underscore fee is equal to null. Let me execute that one. So you know P5 and P9, these are the two values which has null values, this patient IDs. Now, when you see the main query, first this query gets executed and the value is P5 and P9. So this value will be fed here. Then the select statement, what will happen? It will be like select patient name from patient, where patient in C5, P5, comma P9. You can see this one here. So what I did, this is a separate table patient, and this is a separate table called as patient underscore visit. I am combining these two tables with the help of the subquery. First, I found out the information about the patients who are not paid fees. So I got P5 and P9 as a value. This P5 and P9 is fed as the input to this outer query, and finally it is able to find the patient names. So Vaishali and Jim have not paid the fees so far. Now, instead of using null value, I am using this subquery with not null value. There is the only difference here. Here, other than P5 and P9, all records should have been executed, and those records would have been passed as an input to this query, and that is why you get all of this information and you don't see Vaishali and Jim here. Now the conclusion is these guys have paid the patient fees, and Jim and Vaishali have not paid the professional fees so far. This aggregate functions, very simple functions. I am querying the data from this patient underscore visit. Minimum fee is $100. Maximum fee is $250. Sum of all fees is equal to $1,170. Average of all visit fees is equal to 146.25. And then count of visit fee is equal to 8 records. That's what we have seen here. These are all called as aggregate functions, and these functions will be very useful when you are working in the data warehouse data model, because most of the facts measures that will rely on this aggregate functions like minimum, maximum, sum, average, and as well as count. Let me clear the screen. I'll go to the next one now. In this aggregate functions, we do have a function called as group by and a class called having. In the normal statement select statement, we use where statements, whereas in the group by class, I will try to use it with having class. Let me try to execute this statement first. Now, visit fee, that is 100. Count of visit fee, it says 3. From patient visit, group by visit fee. So what it has done, it has grouped all the values in the visit fee column, and then it gives the number of values, that is 100 value is found 3 times in this table. Then 120, it's found 1 time in this table. Null values 0 times found. 250, 1 time found. Okay, that is the use of group by class. Now I'm going to combine this group by with having class to get more clarity. Now you can see having. That means look, it's similar to where class, and it says count of visit fee is greater than 1. Wherever you see visit fee is greater than 1, try to fetch those records. Now in the above example you have seen 100 has appeared 3 times and 150 has appeared 2 times. So these 2 records are pulled from the database and it shows the results here. Then I'm talking about ascending and descending. So when you see this one, just it's sorted out here 100 to 250, whereas here from null to 100. Now the next one is unique constraint. In the earlier class, I described about the primary and unique key constraint. So primary constraint is a constraint imposed the column, and in the database you can see a unique constraint created, then an index created, and it not allow null values. Where in the case of unique constraint, it will allow null values, but unique constraint will be created. So let me try to do something with this alter table statement. Here, alter table is the syntax, patient is a table name, drop constraint is the syntax, and unique underscore SSN is the constraint name. Let me try to drop it. If this constraint is already present in the database, then this will be dropped. Otherwise, it will say no record selected. Semicolon is the end of statement, so I'm pressing semicolon, just press enter key. So table altered, that means this unique constraint is created now. Then unique constraint with this drop clause has been dropped now. In the next statement, I'll try to add the constraint, unique constraint here. Here what do you see? Alter table patient. Alter table syntax, patient is the table name, add constraint is the syntax, unique underscore SSN is the unique constraint name, unique is the syntax, and SSN is the column name. That means we are imposing a unique constraint on this column SSN, which is present in this table called as patient, and we are giving the unique constraint name as unique underscore SSN. Now, to check how unique constraint works, I'm going to do some kind of select statements here. Let us see how it works. Okay, you can see patient ID and SSN from patient. That's what I'm querying. P14 SSN, it contains null values here. Out of these 15 records, you can see null values here. What we did earlier, we imposed a unique constraint on this column called SSN. Even though it had null values here, the unique constraint has been imposed. That's what I'm repeatedly saying, that primary key will not allow null values, whereas unique constraint will allow null values. Then I'm trying to insert P12 and P13, 2 records here. Let us go to the, okay. If you see this one, insert into patient values P12, it says patient underscore ID, unique constraint violated, because we do have a primary key on this column called patient underscore ID, and I am again trying to insert values P12 and P13, so it is not allowing me to do that one. Fine. So what I'm going to do, here I'm going to delete these 2 records P15. Okay, if you want to modify this null to not null, you can do this one, alter table modify SSN null. You get a message from Oracle and it says that column to be modified to null cannot be modified to null. That means describe this table patient. Fine. Already we do have SSN column as a null value here, and that is why it says already this column is null and it cannot be modified to null. Now the next step, what you can think, okay, let me modify this SSN to not null. Fine. But you have to remember that we do have null values in that particular column. So I will repeat the same statement, alter table in a different way now. Alter table patient, modify SSN varchar to 11 not null. Now it says null values are found in those two columns, and that is why I am not able to give unique constraint. Now in this situation we will try to do in a different way now. We will select patient underscore ID from patient where SSN is null. So P14 and P15, these are the two columns which has got null values here. So we will try to update this value. We'll say update patient table, set SSN equal to 976543210, where patient underscore ID equal to P14. So I'm trying to update this P14 with some value. So it says 040 rows updated. Okay. So what I will do, I'll change this one to lowercase P14 and execute it. So it shows one row updated. Then we'll come to this record P15 and we'll try to update that record also. Here what I will do, I'll try to do 3211 and then I'll give this one as P15. Now it says one row updated. Let me commit, okay, so that this data is pushed permanently into the database. Now I'll try to update that social security number to not null. Okay, so this is what I'm going to impose now. Alter table patient modification variable not null. Okay. Now you get the message table altered. So you can see the difference in the unique constraint. It allows null values, and after that, when null values are there, you had problem in updating that column to not null. So I updated SSN with the two values. Then the system accepts that one. Now it has become not null here. Let me clear the screen now. Now I'm going to delete this patient P15 and P14. So it says rows deleted. Then I'll try to insert same P14 and P15. So it says cannot insert null into SSN. Fine. So that is a problem. Earlier it was null. So it had the privilege to allow null values. Now in this situation, to avoid this error, we have to update this column. We'll give a random social security number 1 2 3 3 3. So we have provided the SSN and we'll try to execute this one now. Right? So it says one row created. Now we'll try to execute this P14 also with another social security number. Whatever errors we had in the previous set, this will not happen here because we are trying to feed some values to the social security number. I'm giving a random number. Okay, there is no meaning in this one. All you have to understand is the concept behind null, not null, so that you get familiar with the data modeling concepts. Then I'm going to a different section called as index. Index is a database object which is used for pulling out data in a faster manner. You see the telephone book. If the telephone book doesn't have index, you may not be able to pull the data quickly. You see the dictionary. If the dictionary is not having index like A, B, C, D, E, it will be very difficult for you to pull out the data. When you have the index, it makes the search easier. The same concept is followed in the Oracle database also, in other database also. Whenever you do an index, it pulls the data quickly from the database. Now, let me try to add drop. If there is an index by name, index patient name, it will be dropped. Otherwise, it will say no such index name. So, an index name is there. I drop that index. Then I'm trying to create an index here. I create this index here. It has been created. If you want to see where are those indexes placed in Oracle, you go to this table called all underscore int underscore columns. This is very important. You need to understand this concept. So this system defined table. This table is created by Oracle. Whenever indexes are created by the users, all data is stored here. I am trying to define the data structure for this table all underscore int underscore columns. You see different columns here. Out of those columns, I'm going to pick some columns and go ahead. Here, I'm trying to pull the index data for this table called as patient visit. There, what I want to see is index name, table name, column name, and column position. So it says quoted string. Okay, I don't have the quoted string here. I give the quoted string here. If you remember, in our first module, we had foreign key indexes and as well as primary key indexes. If you remember, in this patient visit table, we had this clinic underscore ID column. This is a primary key. Doctor underscore ID. This was a part of the primary key. Patient underscore ID. This was the part of the primary key. And visit underscore date was also part of the primary key. And that is why in this table it shows you got the index name is PK patient visit underscore PK01, and then the table name is patient underscore visit. The column name is clinic underscore ID. Since you have a composite primary key here, those are numbered as 1, 2, 3, and 4. That's what you see here. Remember this table, which will be very useful to pull out the indexes and drop and add as you like. Then I go to another section where I'm going to speak something about the constraints and as well as how to add column, rename column, and as well as drop column. Now I'm adding a column date of birth here. Describe patient. So you can see this column date of birth here, date of birth, date. Then what I do, I alter this column name to a different column name. Now date of birth I'm renaming that column name to DOB. Again, I will describe this patient table for more clarity. Here you can see this date of birth has been updated to DOB. So finally, I'll drop that column also DOB. Now you get the message table altered. That means this column is dropped. Let me try to describe the table now. Describe patient. So you don't see that column date of birth or DOB because we dropped that column DOB here. Now there is a system defined table called user underscore constraints, which will show all the constraints that are present in different tables. Let me describe the table structure now. Describe user underscore constraint. This is the table structure. You have constraint name, constraint name, so many things here. One by one, I'll try to execute how to find out the constraint name. That is our intention. Now, what I'm trying to do here is I'm executing this query on this user underscore constraints on this patient table, and I would like to find out distinct constraint types. So let me go to this patient table. What you see here, on SSN we impose unique constraint, and that is why you are seeing U here. That means unique constraint. Then all columns are not null here, and that is why you see this C here which says not null. Primary key, you know that we impose that one on the patient ID, and that is why we are getting this P. So on this table we have three distinct types U, P and C. Let me go to the other table now. Describe patient underscore visit. We have not imposed any unique constraint on this table, so unique constraint U should not appear here. Describe patient underscore visit. Let me change the table name here. Instead of patient, I'll say patient underscore visit. You don't see that C there, RPC. Fine. P is the primary key which is imposed on combination of columns clinic, doctor, patient ID and visit date. And this R means it's a referential integrity constraint. Clinic ID is referencing to clinic table, doctor ID is referencing to doctor table, and patient ID is referencing to patient table. And that is why you see this R constraint here. There is another column we have to find out the constraint name and the columns associated with that constraint name. For that we have another table called as user underscore cons underscore columns. First what I will do, let me execute this. PK underscore patient underscore ID. If you see this command, I am querying this user cons columns table where constraint name is equal to PK patient ID. So it takes time, or at times like it may be hanging also. You never know about that one. So what I will do, I'll try to execute it once again. Yeah, so it was hanging, and once again I execute that one. You can see this one, PK patient ID is the primary key, and this table name is patient, column name is patient underscore ID, and the constraint name is pk patient ID. So we are able to find out the table name and as well as the column name associated with this primary key. Now why it takes time here? It has to search lot of tables, lot of data, and that is why it takes time to pull the data from the system defined tables. Now if you see here, you see the condition here. This is a subquery. Okay, this is a nested query. Select constraint name from user constraints where constraint type is equal to P and table name is equal to patient. So in the inner query, what would have happened? It would have given the constraint name with these where clauses, constraint type is equal to P and table name is equal to patient. That means what Oracle would have done, it was searched for this table name called as patient and with constraint type is equal to P. Then what would have been the result? The same constraint name, that is this pk underscore patient underscore ID, you would have got from this user underscore constraint system defined table. Then we pass this constraint name, which is pk underscore patient underscore ID here to this outer query or to the main query, and that is why you see this messages here. So this user cons columns and user constraints, these two tables are very important from the data modeling perspective. You need to understand how to query those tables and get the right information, so that it will be very easy for you to drop constraints, create constraints, and as well as drop indexes and add indexes. So in this module, we have learned a few information about how to query the tables, how to group by, how to do having a class in the group by section, and different aggregate functions. And apart from that, we have done some kind of alter statements also. So my sincere request is, from the first session where we were talking about this create table, alter table, kindly go through that one, read each and every statement, purposely do mistakes on Oracle database, take out comma, add quotes, remove quotes. You do these things regularly and you'll become a master of the database, which will be really, really useful for you to construct a good data modeling career. That's all for now. Thanks. Bye.